Hello everyone. Today we are going to talk about Chapter 1.1 Introduction to the Particulate Nature of Matter and Chemical Change, which is part of Topic 1 Stoichiometric Relationships. The video is based on Chemistry IB Textbook 2nd edition. The contents of this video are: what is stoichiometric relationship, elements, compounds, and mixtures, changes of states, chemical equations, and last, we're going to go through an example question covering this unit. First of all, what is stoichiometric relationship? As said in the IB textbook, stoichiometry describes the relationships between the amounts of reactant and products during chemical reactions. So stoichiometry enables chemists to determine what amounts of substances they should react together and enable them to predict how much product will be obtained. Matter is divided into two big categories, which are pure substance and mixture. Pure substances have only one element or compound. On the other hand, mixture consists of two or more substances in which no chemical combination has occurred. Pure substance is classified into elements and compounds. Elements are completely made of one type of atom such as oxygen, hydrogen, and lithium. A compound is a chemical combination of different elements containing a fixed ratio of atoms such as H2O, which you know is water, NaCl, which is salt, and C6H12O6 called glucose, which is sugar inside your blood. Meanwhile, mixture can be also classified into two types, homogeneous and heterogeneous. Homogeneous mixture has uniform composition and properties throughout. For example, sea, water, and air are homogeneous mixtures, which means that in any part of the mixtures, the substances are evenly mixed. However, a heterogeneous mixture's properties are not the same throughout. For example, soil water and oil and water are both non-uniform. They are mixed unevenly. Changes of states. States changes as energy transfers. Remember that state changes occur at fixed temperature and pressure, and that the changes of states are reversible. When solid becomes liquid, it is called melting. The other way around is freezing. When liquid becomes gas, it is boiling. The other way around is condensation. Lastly, when gas becomes solid, it is deposition. The other way around is sublimation. All the red arrows indicate the endothermic reaction, which is reaction absorbing heat, and all the blue arrows show the exothermic reaction, which is reaction releasing heat. So the matter absorbs heat when solid becomes liquid and gas, and when liquid becomes gas. Also, the matter releases heat when gas changes into solid and liquid, and when liquid becomes solid. Chemical equations represent the undergoing chemical change using chemical symbols of the simplest ratio of atoms. The left-hand side are the reactants, and the right-hand side are the product of chemical reaction. The numbers written in front of each term are coefficients. If there is no number such as CH4 and CO2 in the shown equation, it means that their coefficients are 1. Since the coefficients show the number of units of each term, and atoms neither created nor destroyed during chemical reaction, the total number of each element must be the same on the both sides of the equation. Now, let's practice balancing chemical equations. First of all, balancing chemical equations means finding the coefficients of each term. As I said before, the total number of atoms must be the same on both sides. Most of the time, it is easier for you to balance the equation with the atom which is contained least in the terms. For example, in the given equation here, oxygen is included in 3 terms: O2, CO2, and H2O. However, carbon and hydrogen are each included in 2 terms, so I would prefer to choose carbon or hydrogen rather than oxygen to start with. In this solution, I'll start with hydrogen. There are 4 hydrogen atoms in CH4 on the left-hand side and 2 hydrogen atoms in H2O on the right-hand side. Once more, the hydrogen atom number on the left-hand side and the right-hand side should be the same. To balance hydrogen, what should each coefficient be? It should be 1 on CH4 and 2 on H2O, because 1 times 4 is 4 and 2 times 2 is 4. Then this time let's balance the carbon atoms. The total carbon atom on the left-hand side is 1, so the coefficient of CO2 should also be 1. Lastly, oxygen. There are 2 oxygen atoms in CO2 and the coefficient of it is 1. And there is 1 oxygen atom in H2O and the coefficient of it is 2. So the total oxygen atoms on the right-hand side is 1 times 2 plus 2 times 1, which is equal to 4. What would be the coefficient of O2 then? It would be 2 because the oxygen in O2 has 2 atoms and the total oxygen atoms should be 4 on both sides.